Welcome to the EAPCET mathematics program. We finished ellipse in the last episode. We are now taking up the discussion of hyperbola, which is one of the central concepts in the secondary syllabus of the intermediate mathematics. Just we will quickly go through the important aspects of this second degree curve, hyperbola. Like ellipse, hyperbola has certain similarities with the ellipse as far as the results are concerned, because most of the results you can obtain by replacing b square by minus b square in the equation of the ellipse. For example, the standard equation of the ellipse is x square by a square plus y square b square equal to 1, and that of the hyperbola is x square by a square minus y square b square equal to 1. So, we will point out what results can be obtained from the corresponding results for ellipse by replacing b square by minus b square. Let us have a look at the screen and also see the important aspects of hyperbola. Standard equation x square by a square minus y square b square equal to 1. Here there is no connection between a and b, like a less than b or a greater than b or a equal to b. So, a b can be anything as long as they are positive numbers, that is all. No order relation between a and b like in the case of ellipse. For the hyperbola h, we denote this curve represented by the standard equation x square by a square minus y square b square equal to 1 by h. The transverse axis and the conjugate axis, they are major axis and minor axis. Here transverse axis is along the x axis and is of length 2a, and the conjugate axis is along the y axis and that is of length 2b. In fact, the curve does not intersect the y axis. It does not intersect the y axis in real points, but still if you take 2 points on the y axis, namely 0 b and 0 minus b on the y axis, the line segment joining these two is called the conjugate axis, whose length is 2b. Center is once again origin. Vertices are same as plus or minus a comma 0. Eccentricity, e, look at here. In the case of ellipse, that is root of a square minus b square by a. Of course, there a greater than b. But here, regardless whether a greater than b or less than b or equal to b, the eccentricity is given by root of a square plus b square by a. This is always greater than 1, because root of a square is a, root of a square b square is always greater than root of a square. Therefore, there is always greater than 1. Or the relation connecting the semi-transverse and semi-conjugate axis and also involving the eccentricity of the hyperbola is given by b square equal to a square into e square minus 1. Foci plus or minus a 0, same as in the case of ellipse. Corresponding directrices, directrix corresponding to the focus a comma 0 is x equal to a by e, and the other directrix corresponding to the other focus minus a comma 0 is x equal to minus a by e. Well, these are same as in the case of ellipse. Lattice rectum 2b square by a, length of the lattice rectum, same as in the case of ellipse. Asymptotes, this is one, of course, important thing here. Of course, there are a pair of lines associated with the hyperbola which have a typical behavior, and these are lines passing through the center of the hyperbola, whose equations are x by a plus or minus y by b equal to 0. Their combined equation is x square by a square minus y square b square equal to 0, differs from the standard equation by constant. Even if the equation of the hyperbola is not in the standard form, this is the case. Regardless how you express the equation of the hyperbola as a second degree equation x and y, the combined equation of the asymptotes always differs from the equation of the hyperbola, left hand equation of the hyperbola only by a constant. Important results. Suppose I denote by h the hyperbola x square by a square minus y square b square equal to 1. In the case of ellipse, the sum of the focal distances of any point on the ellipse is a constant, that is always equal to length of the major axis. And here the difference of the focal distances of any point in the hyperbola is always a constant, that is equal to 2a, which is the length of the transverse axis. And then angle between the asymptotes, x by a plus or minus y by b equal to 0. Now, these are a pair of lines passing through the origin having slopes b by a and minus b by a. One can easily see that the angle between these two asymptotes is 2 tan inverse b by a. But because a and b are connected by b square equal to a square into e square minus 1, this can be also written as a twice arc secant e. If a greater than b, the locus of the point of intersection of perpendicular tangents drawn to the hyperbola is the circle concentric with the hyperbola, whose radius is the root of a square minus b square. This circle exists only when a greater than b. When a less than b, you cannot draw perpendicular tangents to the hyperbola. Therefore, here is the restriction on a and b for the existence of the direct arc circle, that the transverse axis must be of length having length greater than that of the conjugate axis. The equation is x square plus y square equal to a square minus b square. Auxiliary circle, same as in the case of ellipse, x square plus y square equal to a square. Once again, this is the locus of the feet of the perpendiculars are drawn from the foci onto any tangent drawn to the hyperbola. Then parametric equations of the hyperbola x square by a square minus y square b square equal to 1. They are given by x equal to a secant theta, y equal to b tan theta, where theta can range between 0 and 2 pi, but theta not assuming either of these two values pi by 2 and 3 pi by 2. Conjugate hyperbola. The conjugate hyperbola of a hyperbola is the hyperbola having the transverse and the conjugate axis same as the conjugate and transverse axis of a given hyperbola. For the given hyperbola, the center is the same for both. For the hyperbola h, the conjugate axis is along the y-axis. For the conjugate hyperbola, the conjugate axis will be, the transverse axis will be along the y-axis. For the given hyperbola, transverse axis is along the x-axis. So, for the conjugate hyperbola, the conjugate axis will be along the x-axis, and therefore, the equation of the conjugate hyperbola is y square by b square minus x square by a square equal to 1, or sometimes you can also write it as x square by a square minus y square by b square equal to minus 1. Observe that the hyperbola x square by a square minus y square b square equal to 1, and also x square by a square minus y square b square equal to minus 1, both hyperbola and its conjugate have the same pair of lines as asymptotes. The asymptotes for both these hyperbolas are the same pair of lines, x by a plus or minus y by b equal to 0. Also, one more important result written as point number 15 here. The product of the perpendicular distances drawn from any point on the hyperbola to the asymptotes is always constant. You take any point x naught y naught on the hyperbola, x square by a square minus y square b square equal to 1. Because x naught square by a square minus y naught square by b square equal to 1, the product of the lengths of the perpendiculars drawn from x naught y naught to the two asymptotes x by a plus or minus y by b equal to 0 is always constant. That does not depend on the choice of the point P in the hyperbola. It is independent of the coordinates x naught and y naught of the point P chosen on the hyperbola. Whereas this product is equal to a square b square by a square plus b square. Several times questions, numerical questions are asked on this formula. A square b square by a square plus b square. One should keep a note of this last result. Then tangent to the hyperbola at x naught y naught, same as ellipse when you replace b square by minus b square. Here x naught by a square minus y naught by b square equal to 1, but not the normal. Normal I think you had, because you cannot simply replace b square by minus b square to get the normal here. Tangent at the point theta is, first of all, tangent at the point theta is x secant theta by a minus y tan theta by b equal to 1. Parametric form of the tangent equation. Normal at the point theta is ax by secant theta plus by by tan theta equal to a square minus a square plus b square, which is a square e square. There a square minus b square is a square e square. In the case of hyperbola, a square plus b square equal to a square e square. The normal equation is ax by secant theta plus by tan theta equal to a square e square. Condition for tangency, the line y equal to mx plus c is the tangent to the hyperbola if and only if c square equal to a square m square plus b square. The line x cos alpha plus y sin alpha equal to p, similar result was also discussed in the case of ellipse. This same line whose equation is in the normal form is the tangent to the ellipse if and only if p square equal to a square cos squared alpha plus b square sin squared alpha, and here the analogous condition is p square equal to a square cos squared alpha minus b square sin squared alpha. Please make a note of this. స్టూడెంట్స్ ఇంటర్మీడియట్లో దీని గురించి పెద్దగా పట్టించుకోరు, కానీ ఇది చాలా హెల్ప్ చేస్తుంది మనం ప్రాబ్లమ్స్ ఈజీగా చేయడానికి. నెక్స్ట్, ది హైపర్బోలా ఎక్స్ స్క్వేర్ బై ఏ స్క్వేర్ మైనస్ వై స్క్వేర్ బై బీ స్క్వేర్ ఈక్వల్ టు 1 is called a rectangular hyperbola if a equal to b. You know why? The reason it is called rectangular. Rectangular means something perpendicular. There are a pair of lines which are perpendicular that are associated with the hyperbola. What are they? Asymptotes. When a equal to b, you can easily see that the asymptotes are x by a plus or minus y by a equal to 0 or x plus or minus y equal to 0. One asymptote is x plus y equal to 0, the other is x minus y equal to 0, which are clearly perpendicular. And therefore, the hyperbola itself is called a rectangular hyperbola in this special case when the transverse and conjugate axes are of the same length. And its standard equation is x square by x square minus y square equal to a square, referred to the transverse axis as the x axis and the conjugate axis as the y axis. Sometimes there is another way of putting the equation of the rectangular hyperbola by choosing the axis of coordinates in a different way. Because the asymptotes are perpendicular for a rectangular hyperbola, well, see, it is curious to know, to find what happens to the equation of the rectangular hyperbola in case one chooses the pair of asymptotes as the axis of coordinates. In that case, you can reduce the equation of the rectangular hyperbola in one of the two forms, xy equal to c square and xy equal to minus c square, depending on the direction of rotation. Then, product of the perpendicular distances of the foci onto any tangent drawn to the hyperbola is also same as b square, like in the case of ellipse. Finally, if E is the eccentricity of a hyperbola and even is the eccentricity of its conjugate, then these two are connected by the relation 1 by E square plus 1 by E1 square equal to 1. Now, all these things I think you find in the intermediate text, nothing special, but only as a matter of revision, we prefer to discuss these things before we take up the practice. Now, let us go to the practice on hyperbola. Question number 1. If the eccentricity of a hyperbola is root 3, E equal to root 3, what is the eccentricity of the conjugate hyperbola? 2006 EAPCET. 1 by E square plus 1 by E1 square is 1. 1 by 3 plus 1 by E1 square, that is 1, or 1 by E1 square equal to 1 minus 1 by 3, 2 by 3, or E1 equal to square root of 3 by 2, because E1 square is 3 by 2. So, the third option easy. The foci of the hyperbola 9x square minus 16y square plus 18x plus 32y minus 151 equal to 0 or 89 EAPCET. Well, we have to first of all reduce this equation to the standard form by translating the axis to a suitable, which is the center of the hyperbola. So, 9 times x plus 1 whole square minus 16 times y minus 1 whole square equal to 144. Okay. Or capital X square by 16 minus capital Y square by 9 equal to 1. With reference to 1 minus 1 1 as origin. If you translate the axis to the point minus 1 1, which is the center of the hyperbola, this is hyperbola is reduced to the standard form, x square by 16 minus y square by 9 equal to 1. So, what are the foci? Plus or minus a is 0, a is a square plus b square is a square e square, 16 plus 9 25, that is a square e square. So, a is 5. So, plus or minus 5 0 with respect to minus 1 as the origin. So, in the given coordinate system, what are they? Add the x and y coordinates of the origin or the new origin to the coordinates of the foci. 5 plus minus 1 4, 1, minus 5 minus 1 minus 6 1. So, these are the in the given system. Given coordinate frame. So, 4 1 and minus 6 1, that is option 4. Next, the distance between the foci of the hyperbola x square minus 3y square minus 4x minus 6y minus 11 equal to 0 is. Well, once again we have a case to reduce the equation to the standard form, x minus 2 whole square minus 3 into y plus 1 whole square is equal to 4 minus 3 1 12, or x square by 12 minus y square by 4 equal to 1 with reference to 2 minus 1 as origin. Because they are asking the distance between the foci, well, there is no need to write this also. Then you need to translate also. So, what are the foci? Because the distance is required, well, it does not depend on the choice of the axis of coordinates. Distance between the foci remains the same, whatever be the coordinate system. So, foci here are plus or minus a0. A square g square is 12 plus 4, 16, so 40. So, what is the distance between the two foci? 40 and minus 40. Whether in the new coordinate system or old coordinate system, distance is the same, that is 8. Follow? If a equal to 40 and b equal to minus 40, the locus of p such that mod pa minus pb equal to 4. Just now we discussed the geometric property of the hyperbola. Here the distance of p from a and b, the difference of the distances of p from a and b is always constant, that is equal to 4. ఒక xy ప్లేన్లో ఒక వేరియబుల్ పాయింట్ కనుక రెండు ఫిక్స్డ్ పాయింట్స్, ఇక్కడ రెండు ఫిక్స్డ్ పాయింట్స్ ఏబీలు నుంచి వాటి దూరాల మధ్య వ్యత్యాసం స్థిర సంఖ్య అయినట్లయితే ఆ బిందువు యొక్క బిందు పదం అతి పరావళయం. ఇది జామెట్రిక్ ప్రాపర్టీ ఆఫ్ ది హైపర్బోలా. ఇక్కడ దిర్ఫర్ అక్కడ ఆ కాన్స్టెంట్ ఏమవుతుంది? లెంగ్త్ ఆఫ్ ది మేజర్ యాక్సిస్, ద ట్రాన్స్వర్స్ యాక్సిస్ అవుతుంది. సో 2a4 ఏబీలు ఏమవుతాయి? దానికి ఫోసై అవుతాయి. సో ఏఈ ఈక్వల్ టు 4. So, E equal to 2 and B square equal to A square into E square minus 1, 12. So, what is the equation of the hyperbola? X square by A square minus Y square by B square equal to 1 is the hyperbola, or 3x square minus Y square equal to 12. Follow? Well, this is the second option. The equation of the hyperbola referred to its axis as the axis of coordinates. Axis means the transverse, usually this tradition is the transverse axis x-axis and conjugate axis along the y-axis. And who the distance between the foci is 16, that means twice AE is 16, so AE is 8. And E is root 2, that means a rectangular hyperbola. Therefore, E equal to 8 by root 2. Or 4 root 2. So, what is the equation? X square minus y square okay. At E is not 4 root 2, eccentricity root 2. This is A is 4 root 2. And also equal to B, because when root 2 means it is rectangular hyperbola, same axis must be the same length. So, x square minus y square equal to A square, that is 32. Okay. 6. The product of the distances from any point on the hyperbola to its asymptotes is, just now we discussed the formula. It is a square b square by a square plus b square. ఇవి just 5 to 10 secondsలో చేసేయాలి ఇలాంటివి. 93 MCET question paper. A square is 16, b square is 9 by a square plus b square is 25. So, 144 by 25. There is no need also to write anything on paper. You can straight away you can read through by going through the statement of the question. 7. Points at which the tangents to the hyperbola y equal to x minus 1 by x plus 1 are parallel to the line y equal to x plus 1 are. Well, that is how the paper question appeared in the question paper of 93 MCET. So, you need not worry about the doubt about the nature of the curve represented by the equation y equal to x minus 1 by x plus 1. So, that is of course a hyperbola that is given. So, parallel to the line. Tangents are parallel to the line means what are the points on this hyperbola at which the tangents have slope equal to 2. Use calculus, d by dx y equal to 1 minus 2 by x plus 1, that is x minus 1 by x plus 1, d by dx 2 by x plus 1 whole square. This is equal to 2 if and only if x plus 1 whole square equal to 1, or if and only if x plus 1 equal to plus or minus 1, if and only if x equal to 0 or minus 2. When x equal to 0, the point is minus 1 on the hyperbola. When x equal to minus 2, minus 3 by minus 1, that is 3. Well, this is the third option. These are the points on the hyperbola at which the tangents are drawn to the curve are parallel to the given straight line y equal to 2x plus 1. 8. The combined equation of the asymptotes of the hyperbola xy plus x plus y plus 5 equal to 0 is. As I told you earlier, the combined equation of the hyperbola differs from the equation of the combined equation of the asymptotes y only by constant. So, x plus y plus x plus y plus k equal to 0, because in the place of 5 I put k. Because this is a pair of straight lines whose combined equation is this, you must be able to split this left hand member as the product of two linear factors in x and y. అంటే తెలుగులో ఇది కనుక కంబైన్డ్ ఈక్వేషన్ ఆఫ్ ది పేర్ ఆఫ్ అసిమ్ప్టోట్స్ రిప్రజెంట్ చేయాలంటే xy ప్లస్ x ప్లస్ y ప్లస్ kని xyలలో రెండు ప్రథమ తరగతి కారణాంకాల లబ్ధం కింద xyలో రెండు ఫస్ట్ డిగ్రీ ఎక్స్ప్రెషన్స్ యొక్క ప్రోడక్ట్ కింద రాయగలిగి ఉండాలి. క్లియర్లీ k1కి సరిపోతుంది. ఇది value of k for which this can be factored into two linear factors in x and y is 1. Then x plus 1 into, because from this you can take x into y plus 1. Plus if k is 1 only, then this will be x plus 1 into y plus 1 equal to 0. So, this is the combined equation. Follow? The equation of the conic with focus at 1 minus 1, directrix x minus y plus 1 equal to 0 and eccentricity root 2 is rectangular hyperbola once again, 94 EAPCET question. So, use the focus the directrix property of the hyperbola of a conic SP equal to E times PM. This is the focus directrix property. E square is 2 PM square. S of course is 1 minus 1. P is xy, any point on the curve. So, what is SP square? X minus 1 whole square plus y plus 1 whole square into PM x minus y plus 1 by root 2. Distance formula, perpendicular distance of xy from x minus y plus 1 directrix, that is x minus y plus 1 equal to 0 is x minus y plus 1 by square root 2 whole square, x minus y plus 1 whole square by 2 into 2 x minus y plus 1 whole square. So, x square plus y square terms both sides will cancel out, minus 2xy bring this side 2xy plus 2x bring this side minus 2x minus 4x plus 2y minus 2y plus 4y plus 1 plus 2 minus 1 plus 1 equal to 0. So, this is the equation of the rectangular hyperbola with focus at 1 minus 1 and directrix along the line x minus y plus 1 equal to 0. So, therefore, that is the second or third option. If E and E1 are the eccentricities of the two hyperbolas xy equal to c square and x square minus y square equal to c square, one should observe that x square minus y square equal to c square is the rectangular hyperbola and therefore, its eccentricity is root 2. xy is equal to c square also is the rectangular hyperbola. Just now I have mentioned about this by suitably selecting the axis of coordinates, the second form of the rectangular hyperbola can be reduced to the first form xy equal to c square. That is the choosing the asymptotes as the axis of coordinates. So, both are rectangular hyperbolas. So, therefore, E equal to E1 equal to root 2 and therefore, E square plus E1 square equal to 4. That is the second option. Simple question. Question number 11. The angle between the asymptotes of the hyperbola is, it is a 2 tan inverse B by A. That is the angle between the asymptotes. What are A and B? X square by 3 minus y square by 1 equal to 1. That is the hyperbola. What is a B? B is 1 and A is root 3. What arctan 1 by root 3 is a pi by 6. which is therefore equal to pi by 3. So, that is 60 degrees is the angle between the asymptotes for this hyperbola, rectangular hyperbola, not rectangular, sorry, hyperbola only. The length of the lattice rectum of the hyperbola x square minus 4y square equal to 4 is easy question. X square by 4 minus y square by 1 equal to 1. So, length of the lattice rectum is 2b square by a. That is the formula. Both for the ellipse and hyperbola, the formula is the same. So, therefore, b square is 1 and a is 2, that is equal to 1. So, that the first option. The eccentricity of the hyperbola 9x square minus 16y square plus 72x minus 32y minus 16 equal to 0 is. Once again, I think you have a case to reduce this form to the standard form by shifting the origin to a different point in the same plane without changing the directions of the axis of coordinates, or by translating the axis of coordinates to a suitable point. What is that point? It must be the center of the hyperbola. Once you shift the axis to the center of the hyperbola without changing the directions of the axis of coordinates, it must, because in the standard form x square by a square minus y square b square equal to 1, the center is 0, 0. So, therefore, here let us see what is the center. 9 times x square plus 8x, x plus 4 whole square, minus 16 times y square plus 2y, y plus 1 whole square is equal to 144. Minus 16 is there, 144 here. So, you have to add 144 both sides. So, that this becomes a completion of squares. 9 times x plus 4 whole square can be obtained by adding 144 to 9x square plus 72x, and the rest of course minus 16y square minus 32y minus 16 is already minus 16 times y plus 1 whole square, or this is x plus 4 whole square by 16 minus y plus 1 whole square by 9 equal to 1. So, what is the center? Minus 4 minus 1, and therefore, there is no need to care for the because the semi-axis remains the same and eccentricity depends on the semi-axis. So, E square equal to a square plus b square by a square, 25 by 16, and therefore, E equal to 5 by 4. So, that is the first option. Radius of the direct arc circle of the hyperbola x square by 81 minus y square by 36 equal to 1 is. Well, the direct arc circle, because a greater than b, a equal to 9 and b equal to 6, a greater than b. You know, direct arc circle exists only when a greater than b, and the direct arc circle is x square plus y square equal to a square minus b square, that is equal to 45. So, what is the radius of the direct arc circle? Root 45, which is equal to 3 root 5. Well, that is the answer, third option. Well, the locus of the middle points of the chords of the hyperbola 3x square minus 2y square plus 4x minus 6y equal to 0, parallel to the straight line y equal to 2x is. You are asked to find the locus of the middle points of the chords of the hyperbola which are parallel to the straight line y equal to 2x. That means, what are the midpoints of all such chords of the hyperbola which have a slope equal to 2. Suppose x naught y naught is the point on the locus. If and only if x naught y naught is the midpoint of a chord of the hyperbola whose slope is 2. Slope of the chord with midpoint x naught y naught. What is that? S naught equal to S double naught. What is S naught? 3x naught x, that is 3x naught x, 3x square ఉంది కదా, x square x into x అని రాసి ఒక xకి x naught పెడతాం. Minus 2y square means 2y into y, y naught y, follow, plus 4x ఏం చేయాలి, plus 2 into 2x అంటే x ప్లస్ x అని రాస్తాం. ఒక x అని రిప్లేస్ బై x0 మైనస్ 6y మైనస్ 3 ఇంటూ y ప్లస్ y దట్ ఈస్ 6y. ఒక వైకి y0 రాద్దాం ఈక్వల్ టు 0 ఈక్వల్ టు s డబల్ నాట్ సారీ s double naught we need because that's a constant. We are only interested in the xy terms because we want the slope of this line. The slope of a line depends on the coefficients of x and y. In fact, the slope of ax plus by plus c equal to 0 is minus a by b, whatever be the value of c. So, s double naught being a constant doesn't depend on x and y. It depends on only x0 and y0 is a constant as far as the equation of the line is concerned. So, r 3x0 plus 2 into x minus 2 y0 plus 3 into y is equal to some constant k. మిగతా ఉన్న constant xy terms ఇవే is 2. Slope of this chord equals 3x0 plus 2 by 2y0 plus 3 with a negative sign minus is equal to 2. Follow? Or 3x0 plus 4y0 so minus 3 plus 6 minus 2 plus 8 equal to 0. Aru ఇది స్లోప్ ఇక్కడ స్లోప్ కదైతే మైనస్ ఉన్నది ఇంకా. సో దేర్ ఫోర్ దిస్ ఈజ్ ఎ 3x0 minus 4y0 plus 2 minus 6 minus 4 equal to 0. So, therefore, the locus of x0 y0 is 3x minus 4y is equal to 4. Slope of the line ax plus by equal to k is minus a by b. Minus a means minus of 3x0 plus 2 by b means minus of 2y0 plus 3. Therefore, it is a plus. No minus sign. 3x0 plus 2 by 2y0 plus 3 that must be equal to 2. The slope of this line y equal to 2x which gives you the required relation in terms of x0 and y0 giving the locus 3x0 minus 4y0 minus 4 equal to 0 and therefore, the point x0 y0 lies on the locus 3x minus 4y equal to 4 which is a straight line. Well, one can also see that all such straight lines they parallel to the line, they pass through the center of the hyperbola, they are called diameter lines. Next, the equation of a line which touches both the curves y square equal to 4x and 3x square minus 4y square equal to 12 is, what is the straight line which is a common tangent for the parabola y square equal to 4x and also for the hyperbola 3x square minus 4y square equal to 12. ఇట్లాంటప్పుడు దేనికి ట్యాంజెంట్ తీసుకుని రెండో దానికి ట్యాంజెంట్ అవుతుందన్న కండిషన్ వాడాలన్నది మనకు కొద్దిగా మీమాంసగా ఉంటుంది, డౌట్ఫుల్గా ఉంటుంది. కన్వీనియంట్ చూసుకోండి. y స్క్వేర్ ఈక్వల్ టు 4xకి మనకి ఈజీ. y ఈక్వల్ టు mx ప్లస్ ఈజ్ ద ట్యాంజెంట్ ఆఫ్ ది పారాబోలా y స్క్వేర్ ఈక్వల్ టు 4ax if and only if c ఈక్వల్ టు a by m. సో రైట్ ఏ ట్యాంజెంట్ ఫర్ ది hyperbola, apply the condition that is also tangent to the parabola. A tangent to the hyperbola అని h అందాం, parabola అని p అందాం, only to save time. h is you can do it either with the equation of a line which touches one. Or else you can start with a parabola also, no matter ఏది పైన పర్వాలేదు, కన్వీనియన్స్ చూసుకుంటున్నాం అంతే. p is x minus ఇక్కడ 1 parameter రైట్స్ x minus ty plus t square equal to 0. parabola pకి వేసాను ట్యాంజెంట్, ఎందుకంటే దీన్ని ఇలా రాస్తాను y equal to x by t plus t అని. ఇది y equal to mx plus c ఫార్ములా ఉంది. You know the condition for the line y equal to mx plus c to be tangent to the hyperbola x square by a square minus y square b square equal to 1. C square equal to a square m square minus b square is tangent to the hyperbola h x square by 4 minus y square by 3 equal to 1 condition is if and only if c square ante t square, a square is 4, m square is 1 by t square minus b square 3, or if and only if t power 4 plus 3t square minus 4 equal to 0. కొద్ది కేర్ఫుల్గా చేయాలి. ఈక్వేషన్ ఆఫ్ ఏ లైన్ అంటున్నాడు, ఒకటి చాలు. T1 ఇక్కడ ఇలాంటి 4th డిగ్రీ ఈక్వేషన్ కంగారు పడక్కర్లేదు, ఇన్స్పెక్షన్తో వచ్చేస్తుంది. t ఈక్వల్ టు 1 ఒక సొల్యూషన్ దీనికి. సో t ఈక్వల్ టు 1 ఈజ్ ఏ రూట్ ఆఫ్ దిస్, అండ్ దేర్ ఫార్ ది వాల్యూ ఆఫ్ t ఈక్వల్ టు 1 will give you a common tangent for the two curves, which is x minus y plus 1 equal to 0 is a common tangent, or y equal to x plus 1. ఇంకా కామన్ ట్యాంజెంట్స్ ఉంటాయి లేదా అన్నది ఈ t ఈక్వల్ టు 1 అంటే t మైనస్ 1 ఫ్యాక్టర్ తీసేస్తే మిగతా క్యూబిక్ పాలినామియల్ వస్తుంది, దాని రూట్స్ మీద డిపెండ్ అవుతుంది. మనకి లక్కీగా అంత డిఫికల్ట్గా ఎవరి పేపర్లో ఎప్పుడూ y ఈక్వల్ టు x ప్లస్ 1 ఇక్కడ ఇచ్చారు కాబట్టి వీ నీడ్ నాట్ వర్రీ అబౌట్ ది అదర్ కామన్ ట్యాంజెంట్స్ టు ది టూ కర్వ్స్. ఈజ్ వన్ ఆఫ్ ది కామన్ ట్యాంజెంట్స్ టు ది గివెన్ పారాబోలా అండ్ ఆల్సో ది హైపర్బోలా. ఓకే, నెక్స్ట్ 17. One of the foci of a hyperbola is origin, given that one of the foci of the hyperbola is at the origin, and the corresponding directrix, it's like a husband-wife relation in a monogamous society. బహుభార్యత్వం లేనటువంటి సొసైటీలో, అంటే ఒక మనిషికి ఒకే ఒక భార్య, ఒక స్త్రీకి ఒకే ఒక భర్త ఉన్నటువంటి సొసైటీలో భార్యాభర్తల సంబంధం ఎలాంటిదో, ఈ హైపర్బోలా ఎలిప్స్లో ఫోకస్కి డైరెక్ట్రిక్స్ సంబంధం, ఒక ఫోకస్కి ఒకటే డైరెక్ట్రిక్స్ సంబంధించిన ఫోకస్ అంటాం, ఫోకస్ సంబంధించిన డైరెక్ట్రిక్స్ అంటాం అనమాట. ఆ రకంగా ఒకదాని ఫోకస్ని ఇంకో దాని డైరెక్ట్రిక్స్తో మనం అనుసంధానం చేయకూడదు, తప్పది. సో ఆరిజిన్ ఒక ఫోకస్ అని ఇచ్చారు, దానికి సంబంధించినటువంటి డైరెక్ట్రిక్స్ అంటే నీతిరేఖ 3x ప్లస్ 4y ప్లస్ 1 ఈక్వల్ 0, ఎక్సెంట్రిసిటీ ఈక్వల్ √5 ఇచ్చారు, ఈక్వేషన్ ఆఫ్ హైపర్బోలా అంతా ఫీడ్ చేసేసారు ఎంసెట్ పేపర్ ఆఫ్ 98. p ఈక్వల్ టు xy అయితే e స్క్వేర్ టైమ్స్ pm స్క్వేర్ 5 times pm square, if and only sp square, s is focus is origin, so x square plus y square, p is xy, p is a point on the locus. So when p equal to xy, s is the origin, sp square is op square, that is x square plus y square is equal to 5 times pm, distance of p xy from the line 3x plus 4y plus 1 equal to 0, that is 3x plus 4y plus 1 by mod వేయాలనుకోండి, ఆ 3x plus 4y plus 1 by హోల్ స్క్వేర్ రాస్తాం కాబట్టి అక్కర్లేదు, by 5 హోల్ స్క్వేర్, లేకపోతే mod వేయాలి. ఉత్తి డిస్టెన్స్ ఒకటి రాస్తే mod వేయాలి, లేకపోతే అక్కర్లేదు. సో ఒక 5 క్యాన్సిల్ అయిపోతుంది. దిస్ ఈజ్ ఇఫ్ అండ్ ఓన్లీ 5 times x square plus y square equal to 3x plus 4y plus 1 whole square. ఫాలో, ఇంటర్మీడియట్లో కూడా చేస్తాం ఇలాంటివి. హైపర్బోలా ఈక్వేషన్ ఫార్మ్ చేయడం ఉంది ఫోకస్ డైరెక్ట్రిక్స్ ప్రాపర్టీ ఉపయోగించి. 9x square minus 5y square 4x square, 16y square minus 5y square plus 11y square plus xy term 3 into 4 into 2 24xy. ఇక్కడ x టర్మ్ y టర్మ్ లేవు కాబట్టి ఫస్ట్ ఈ టర్మ్స్ ఇక్కడ ఉన్నవే. సో ప్లస్ 6x ప్లస్ 8y ప్లస్ 1 ఈక్వల్ టు 0. సో దట్ ఈస్ హైపర్బోలా ఈక్వేషన్ 4x square plus 11y square plus 24xy plus 6x plus 8y plus 1 equal to 0, which is the third option. The eccentricity of the hyperbola 4x square minus 9y square equal to 2ax plus b square is, దీనికి ఎక్సెంట్రిసిటీ ఎంత అని అడిగారు 99 ఎంసెట్ పేపర్. సో ఈ ఎక్స్ టర్మ్స్ చేయడం తీసుకొచ్చేద్దాం. 4 into x square minus ax by 2, దీనికి ఎంత కలిపితే పర్ఫెక్ట్ స్క్వేర్ అవుతుంది, a by 4 హోల్ స్క్వేర్. అంటే a స్క్వేర్ బై 16, 4 times a స్క్వేర్ బై అంటే a స్క్వేర్ బై 4 కలిపాం, అవతల కూడా కలుపుదాం. minus 9y square is equal to a square by 4 ప్లస్ బీ స్క్వేర్, ఇదేదో సి స్క్వేర్ ఉందాం, మనకి అవసరం లేదు, ఇదో సమ్ కాన్స్టెంట్. ఆర్ ఎక్స్ మైనస్ a/2 హోల్ స్క్వేర్, a/4 హోల్ స్క్వేర్ బై సి స్క్వేర్ బై 4 మైనస్ వై స్క్వేర్ బై సి స్క్వేర్ బై 9 ఈక్వల్ టు 1. ఆ సి స్క్వేర్ ఊరికే అంతా రాయక్కర్ లేకుండా ఏ స్క్వేర్ బై 4 ప్లస్ బీ స్క్వేర్ రాయక్కర్ లేకుండా దాన్ని సి స్క్వేర్ని రాశాను, నష్టమేం లేదు కదా. ఇది ఇప్పుడు స్టాండర్డ్ ఫార్మ్కి వచ్చేసింది, ఎక్సెప్ట్ దట్ ది సెంటర్ ఇస్ a/4 0. So for finding the eccentricity, you need not translate this. You can direct, because the semi-axis lengths remain the same. So therefore, eccentricity E square is a square plus b square into c square plus 4 by c square plus 4 plus c square plus 9 by c square plus by 4, a square plus b square by a square. C square cancel అయిపోతుంది, అదే అడ్వాంటేజ్. 9 plus 4 13 by, and this is 9. Therefore, eccentricity is root 13 by 3. Well, that is the last option. Follow. The product of the lengths of the perpendiculars drawn from any point on the hyperbola x square minus y square equal to 8 to its asymptotes is, once again, a standard question. Is dependent on the formula a square b square by a square plus b square. You can see both the semi-axes are same here. A square equal to 8 and b square equal to 8. So a and b both are equal to root 2. So this is 8 into 8 by 8 plus 8, which is equal to 4. Simple question. 20. The eccentricity of the hyperbola x square by a square minus y square by b square equal to 1, which passes through the point 3 comma 0 and also another point 3 root 2 is. What is the eccentricity of the hyperbola x square by a square minus y square b square equal to 1 that passes through both the points 3 comma 0 and 3 root 2 comma 2? Yes. Well, because the curve passes through 3 0, a square equal to 9. 9 by a square minus 0 equal to 1 gives a square equal to 9. Okay. It also passes through 3 root 2 2. 3 root 2 whole square is 18 by a square 9 minus 4 by b square equal to 1. This gives a b square equal to 4. Therefore, e square equal to a square plus b square by a square. So 13 by 9. Therefore, e equal to square root 13 by 3. Simple question, last option. Okay. Next. The equation x square by 1 minus r minus y square by 1 plus r equal to 1, r greater than 1 represents. అంటే ఇది మామూలుగా ఎక్స్ స్క్వేర్ బై ఏ స్క్వేర్ మైనస్ వై స్క్వేర్ బీ స్క్వేర్ ఈక్వల్ 1 ఫామ్లో ఉంది కాబట్టి గబాలను జంప్ చేసేస్తాం హైపర్బోలాకి. జేఈ క్వశ్చన్ డిఫికల్ట్ కాదు, కానీ చాలా సటిల్ పాయింట్ అబ్జర్వ్ చేయాలి, చేస్తే అది ఈజీ, చాలా ఈజీ. మామూలు ఎంసెట్లో కొన్ని క్వశ్చన్ల కన్నా ఈజీగా ఉంటాయి జేఈ క్వశ్చన్లు, కానీ క్యాజువల్గా థింక్ చేస్తే మాత్రం పోతుంది, తప్పు వచ్చేస్తుంది. ఇక్కడ ఏమిటి ఆర్ గ్రేటర్ దెన్ 1 కాబట్టి 1 minus r is negative. Okay, this means 1 minus r equal to minus a square. One plus r is also positive. One plus r equal to b square for some b greater than 0. Therefore, the equation takes the form x square by minus a square minus y square by b square equal to 1, or x square by a square plus y square by b square equal to minus 1. Well, this locus, what is the locus of this equation? Well, for any point x y in the complex plane or Euclidean plane or xy plane, x by a whole square plus y by b whole square cannot be negative. The minimum value is 0. That is attained when x is 0 and y is 0. And therefore, otherwise for all other points in the xy plane except 0, 0, this is positive, strictly positive. So, there is no point in the complex plane or xy plane satisfying this equation. So, the graph does not contain even a single point. The graph is the empty set phi, and therefore, it does not represent an ellipse, it does not represent a hyperbola, it does not represent a circle. So, it represents only the empty. The graph has no points. The graph has no points. The graph does not contain even a single point. So, none of these. Simple question. Only thing is that you have to observe that both the quotients of x square and y square in the left hand side of the equation are negative and right hand side is positive. So, straight away the intelligent student does not go for this working, but straight away he guesses that there is no point x y satisfying this equation. If the lattice rectum of a hyperbola through one focus subtends an angle of 60 degrees at the other focus, then what is the eccentricity? Lattice rectum of a hyperbola, ఒక అతి పరావలయం తాలూకు నాభిలంబం, ఒక నాభి గుండా పోయే నాభిలంబం రెండవ నాభి దగ్గర 60 డిగ్రీలు కోణం చేస్తే దాని తాలూకు ఉత్కేంద్రత ఎంత అని అడిగారు తెలుగు మీడియం. సో ఇలా ఉంది హైపర్బోలా. ఇక్కడ ఈ ఫోకస్ తీసుకున్నాం, ఏ 0, ఇదేమో బి స్క్వేర్ బై ఏ, ఇది ఎల్, ఇది ఎల్ డాష్డ్, ఎల్ డాష్డ్ ఇది lattice rectum passing to the focus S dashed is the other focus. L dashed subtends 60 degrees at S dashed. అంటే L dash ని S కి జాయిన్ చేయగా వచ్చిన రెండు లైన్స్ మధ్య యాంగిల్ 60 degrees. అంటే if you join S dash to L and also S dash to L dash, this whole thing is 60. That means this is 30 and this is 30. Both are equal because they are congruent triangles. These two are equal. This is a common and this is a right angle triangle. So, two right angle triangles, if two sides of one equal to two sides of other, they are congruent. So, these two angles must be equal. And therefore, the transverse axis bisects the angle between S dash to L and S dash to L dash. Now, how do you get the eccentricity? Well, this is twice AE, distance between the foci. So, B square by A by twice A square E is equal to tan 30, 1 by root 3. Tan 30 is 1 by root 3, okay? Or B square by A square, E square minus 1 by E is equal to 2 by root 3. So, I transfer 2 to the other side and replace the B square by A square by E square minus 1, because B square equal to A square into E square minus 1. Cross multiply square root 3 times E square minus 2E minus root 3. This can be factored because root 3 into minus root 3 is minus 3, minus 3 into plus 1 is also minus 3, minus 3 plus 1 is minus 2. Therefore, E minus root 3 minus 3E plus E, right, into root 3E plus 1 equal to 0. Well, E is positive, eccentricity is positive. So, this cannot be 0. Root 3 times E plus 1 is always positive. So, only choice is E equal to root 3. So, the eccentricity of the hyperbola is root 3, that is the second option. Follow? Here the lattice rectum is LL dash, subtends an angle of 60 degrees, total angle 60 degrees at the other focus S dash. What is the eccentricity of the hyperbola? I think you followed the solution. Okay, next. The equation of the common tangent to the curves y square equal to 8x and xy equal to minus 1 is. What is the equation of the common tangent to both the curves? Y square equal to 8x and xy equal to minus 1. Well, it is of the form xy equal to minus c square. You see, this is a rectangular hyperbola. So, the big question mark is where to start. That means how to choose the tangent to one of the two curves, whether to first curve or second curve. Well, you know the condition for tangency for the parabolic curve y square equal to 4ax in a line in the slope form y equal to mx plus c is tangent to the parabola y square equal to 4ax if and only if c equal to a by m. But you don't know the condition for a line to be tangent to the rectangular hyperbola xy equal to minus 1. Only you know the condition for tangency for the hyperbola in the standard form x square by a square minus y square by b square equal to 1, which is c square equal to a square m square minus b square. So, because you don't know the condition for tangency for the rectangular hyperbola, you start with the tangent line to the rectangular hyperbola. So, x equal to t, y equal to minus 1 by t. ఇలా తీసుకోవచ్చేమో parametric equations x y equal to minus 1 కాబట్టి x is t and y is minus 1 by t. And therefore, dy dx is y dash at t, which is 1 by t square, by x dash at t is 1. So, the slope of the tangent to the rectangular hyperbola is 1 by t square. So, a tangent to curve C2. C2 is the second curve. X minus t square y. 1 by slope, line with slope 1 by t square is the form x minus t square y equal to. It passes through t minus 1 by t. So, this is 2t or y equal to x by t square minus 2t by t square minus 2 by t. This is in the form y equal to mx plus c. Now, it is easy to apply the condition for tangency for this to the first curve. This is tangent to C1 if and only if c equal to minus 2 by t equal to a means here 2 by m is 1 by t square. So, 2t square. Or if and only if t cubed is minus 1 or t equal to minus 1. So, t equal to minus 1, for the value of t equal to minus 1, this gives the common tangent, which is therefore x minus y equal to minus 2. Or y equal to x plus 2, which is the last option, 2002 joint letter screening. The foci of the ellipse, what are and the hyperbola coincide, confocal conic center. అంటే రెండు ఇంటికి ఒకే ఫోసై ఉన్నాయన్నమాట. సేమ్ పేర్ ఆఫ్ పాయింట్స్ సర్వ్ as the foci for the ellipse as well as the hyperbola. Confocal conic center. ఇది ఇక్కడ దీనికి ఫోసై ఏమిటో చూద్దాం. ఫోసై ఫర్ హెచ్ (144 plus 81), that is 225, that is a square g square plus or minus 15 0. And foci for the, and therefore 15 equal to 16 minus b square well 144, oh here by 1 by 25 is also there, I am sorry. So, 144 by 25, మొట్టమొదటి స్టాండర్డ్ ఈక్వేషన్ రాద్దాం. x square by 144 by 25 minus y square by 81 by 25. ఇదండి ఆ 25 రైట్ హ్యాండ్ సైడ్ చూడలేదు. సో, foci of HR, sum of these two, that is a square g square, which is 229. So, plus or minus 30. These are the foci for the hyperbola. And what are the foci for the ellipse? A square e square, that is 16 minus b square is equal to a square e square, that is equal to 9 here, because the foci are the same for both the curves, which gives b square equal to 7. So, that is 7. Next, the product of the slopes of the tangents drawn from 0 to the hyperbola 5x square minus y square equal to 5 is, well, this is x square by 1 minus y square by 5 equal to 1. Tangent y equal to slope form, y equal to mx plus root of c square a square 1 m square minus b square. This passes through 0 to if and only if 2m whole square 0 2. So, 2 square 4 equal to m square minus 5 or m square equal to 9. So, m equal to plus r. So, slopes are plus or minus 3. So, product of the slopes is minus 9, the third option. The length of the lattice rectum of the hyperbola 16x square minus 9y square plus minus 32x plus 36y minus 164 equal to 0. Once again 16 times x minus 1 whole square minus 9 times y minus 2 whole square equal to 144, or x minus 1 whole square by 9 minus y minus 2 whole square by 16 equal to 1. So, lattice rectum is of length 2b square by a. B square is 16, a is 3. So, 32 by 3. Okay. So, that is the length of the lattice rectum. Okay, we continue this discussion in the next episode. Thank you for giving a patient hearing, and also I think it will be useful to you when you go for the exam. All the best. Good luck. Thank you.